Hey guys, welcome back. It's another episode of Macintosh keyboard hacking. It's been a few weeks since I've been on here, but big project today I think people will be interested in is this new open source scooter display I've been able to put together for the Segway GT3. But before I get into all that, just a real quick follow up on last week, or whenever it was, looking at that SSL bumping. I don't think I did a particularly good job of, explaining what I was getting into there. But this will be applicable to today. So we've got a squid installation, and by getting in that SSL bumping, we're able to monitor. We see a lot of addresses that are inside the ninebot sort of cloud universe there. And I'm not going to go too far with this, but the point of that, in addition to the fact that I accidentally downloaded, oh my God, so much great music, that's where we can get, let's see, yeah, that's where we can get the firmware files from. Kind of like a lot of things do, those files are shipped from like a content distribution network, and yeah, those URLs show right up when we've got the squid on. So from there, um, we're able to get I've spent a little bit of time starting to analyze those. The Bluetooth image is not does not appear to be encrypted, and let's see, I don't think I have anything. Yeah, I didn't really go too far with that. It's not encrypted. All the vehicle MCU images are. I think that's really, I don't think ninebot cares so much that we're hacking the vehicles. I think that they just want to be able to, say whether or not a given vehicle is in warranty or has been tampered with or something like that. So, yeah, there's some text. Looks like an image file there. So yeah, so that was fun. Good way to get some a little bit deeper dive into some of the stuff there. So yeah, myBLEv2 3 series dashboard replacement. I've actually had that up on the site here for a little while, 5 days now, and this is the code that I've been running for several days as a replacement interface. You can see, yeah, basically, it's a ESP32. It's a low-lin module. That is not something I specifically recommend. It's just it was the one part that I could find on Amazon that didn't have the headers pre-soldered, and I wanted something small and compact. So that's there, and yeah, that's all put together in Arduino here. That's the wrong sketch, but that's some of the up-and-coming Bluetooth fixes. But basically, yeah, I've been able to remove the entire stock display and kind of replicate the core functionality with this ESP32 thing here. This is actually kind of, I don't know, quote unquote easy, because Segway really just their engineering and design, the vehicle itself can operate entirely independently from the screen, um, except for some obnoxious beeping and lack of a status display. So what I've done, I've got two different groups of 8 WS2812s. Those are fed from a 5-volt regulator inside there. And the one on the left we're looking at there is the battery level. So each one of those corresponds to 10%. The bottom is 20%. So that's just gives you a range there. That's the big thing I've really found to be useful to have as a control. This scooter doesn't really have any speed issues to be aware of. So I'm not really concerned with how fast I'm going. I just keep up with traffic usually. But so yeah, that being said, so then I do still though have a speedometer function on the left there. Switching in and out, this is a terrible picture, but switching in and out, this upper corner LED changes color based on whether or not I'm in 2 or 4-wheel drive. I'm sorry, yeah, single or all-wheel drive. And then I change colors based on what speed mode it's in. So that should be race mode. And then a couple things there. I've got sort of a, to see how fast I was going, because I can't usually look at the screen when I'm going, full throttle. So there's a bit of a delayed, kind of peak speed readout there. And then the light that we're seeing blinking in the upper corner, that's really the only new feature I've added so far. That's present in the stock interface as well. It's just really hard to see. That gives us an indication whenever the traction control regenerative braking system is kicking in. So the brightness is, it's set on full white to make it visible. And that's actually kind of handy. I just get a little indicator in my periphery vision when, the traction control starts to come in and do some stuff. So yeah, I'm liking that so far. Yeah, so everything else about the vehicle works normally. Not much to see there. That's all, implemented in the ECU. So the VCU is the big one there. Let's see. So we can see what's going on inside of all that. I've just got a little Raspberry Pi here, and then just taken a USB serial adapter. Got a UART just kind of hanging out on a header here. Let's see. Yeah, so data is coming. The scooter is on, and so one of the big functions I've got in this segMod code base, a lot of diagnostic functions, and then I've written a bunch of Python scripts to go along with it to kind of get us into some more fun areas. So as an example, let's just, the naming has gotten ridiculous here. I want me to have 2 serial ports. Which one am I looking for? Just comment that out. Well, that was apparently not what I wanted. All right, so this is an active scanner. In the way that the scooter is right now, there's 2 ECUs for me to talk to. There's the BMS, the battery module, and then the VCU, which is the other half of this display head unit. So in this script I put together, I just poll each of those every 16-bit register. There's 256 per ECU, and I just keep polling those, as often as possible. We can see this first column is the memory offset in that. So that then gets dumped into a file for later analysis. And I've been doing some things. Let's just see. trip to Home Depot. This is it. So as an example, I have a field that, I've been able to identify the field, the register that, in this case, I think that's the battery level. But a lot of interesting things there. I've tried to put all of that in the on the wiki, on the GitHub. So this here is config registers. That's what we're messing with. Some of these are designed to be changed. There's a few sort of secret ones I was able to find. Doing this write scan by trying to see what writes the controller would support. But anyway, plenty of stuff to get into there. I'm in the testing stages of getting Bluetooth functionality back in there. Right now, I am able to connect the stock display just to my Raspberry Pi if I use a USB hub, and I can plug all that stuff in. What that looks like. But that's a man in the middle sort of mode. So probably one of the first things I'm gonna look at once I get a Bluetooth interface of sorts going, probably gonna try and sort of fix all the old apps. Part of the capability in this this segMod code is there's a lot of facilities built for like remapping ECU numbers and parameters. So I think I can just sort of bring up all the old Generation 2, scooter programs. So that'll be nice to have some of those apps back. I want to see if I could get this screen to come on. All right, so now I need my man middle script. So this is the line I was using. There's that's still doing some kind of scanning. All right, yeah, that's a translation one. Okay. Well, I can see something wants to happen because I'm getting traffic on that UART there, but you know how live demos are, things don't always go to plan. But in messing with that, I was able to find some sort of interesting displays hidden in that firmware there. Let's see, let's just go through a little photo show here. Yeah, so on this side of the screen, you have this lovely time lapse of what it took to put all this stuff together. On this side of the screen, stuff work. No, it's because the USB cord fell out. Well, wouldn't be a problem if I could see where it went. That's not button. the old unplug, replug shuffle here. Hey, there we go. All right, yeah, so basically started by taking off the top where the two control boards are. Fairly easy for hex screws there. Once we get inside, we can see some of the quality ninebot stuff. Those cables are all super well sealed and it's all great. So what you got to do, you got to stick the flathead in there and kind of pry them out. That's the way they're designed to work. If you just try and tug on them, you'll wind up, like I did anyway, pulling a bunch of glue and I don't know, that stuff. That's not how you do it. So yeah, here's the actual existing stock BLE module. This is some earlier testing. And then this is the VCU side. This part is different between, for example, the GT3 and like the Max G3 or another model. But I suspect that the display component is pretty similar. Yeah, so that hangs out. That was a way I had previously tapped into the serial port. This is just digging around in that. Okay, so yeah, various combinations of plugging into serial ports and debugging that. And then so wound up using an external voltage reducer to take the 12 volts. This connector here where it comes in from the stem. Taking that 12 volts and regulating it down to 5. This is actually a pair of diodes. There's two pieces where the DC, two DC inputs. I just wanted the most reliable power possible, so I took both. Originally, I was just going to use the micro USB port to get to the module, but I completely destroyed that in the process of putting this thing together. So yeah, I just kind of tapped on to the existing things, and there's the inside, and this was a first attempt to notch out enough space for the micro USB port, but that didn't work out. And yeah, just a side note, I had put some LEDs on there. I removed the front reflector, replaced it with this reflective tape, and that gave me a little hole, nice little place to pull wires through the stem. So that worked out well. So and soldering and all. Yeah, made a little shield between the boards. And yeah, so I made this little tiny, it's a 2mm connector that plugs into the VCU board. That's where that's where we're tapping into the serial port. That's these connectors on this side. And then these go to some ID pins. I've not actually had to use them for anything, so I'm not sure that they're really that important. But and various move it and squeeze it and poke it, and they look like this, which was cool. But like I mentioned, the USB port got broken, and so I couldn't even see how charged my battery was. So that didn't last. I had to take it apart again, and that's where we went with just a pair of couple strips of those WS pixels. And yeah, there's a lot of room in the front and the bottom where the horn is. There's also part of that is plastic, so an RF signal could get through it pretty well. So maybe in the future, put some stuff down in there. And that's the suspension. That's kind of what all that looks like. Yeah, so various layers of tape and squeezing, and we are left with this fancy scooter that yeah, does a great job. The battery gauge is, easy to see. That's one of my priorities. And, the speedometer's there. I don't really care how fast I'm going because there's no rules about that where I live. So while I was messing around with the display, I did a little bit of fuzzing and just kind of sending random bits to it. Uh, Found some of these riding assist modes kind of buried in there. This is the stock firmware that was present on the scooter when I received it in August of this year in the US. So that's not, that's not even any of the new updates, but and then whatever, whatever that's about. And various shots of it in operation. So yeah, that's about it. Next frontier is going to be getting some of these old classic apps to talk to my Bluetooth. And the reason I'm going down that route is because they work without encryption. So that just seemed like a real nice, easy place to start. I think I've gotten it to partially connect. I've gotten it to work entirely in the past. But yeah, just another one with a UART firmware on it. Chapter on the screen. All right, so that's my fake Bluetooth then. Yeah, fake scooter. Stop scanning. And so I'm to the point of, let's we do that with NVR. Yeah, this is a test translation script. In the old days, it was ECU number 22 was the battery. Today in the X3 series, it's 7. So I've written the code where it goes in and tries to, write all that stuff around, but it's not quite working yet. But yeah, coming along. Have some nice dashboard apps, and ultimately, my goal is for continue to be able to use the Segway app like in a stock way, because I do want to continue to be able to receive official Segway firmware updates, because I figure that probably has some safety repercussions in it. So I definitely want all the safety fixes. Oh, this is where my encoding failed. It's a still frame for 4 hours. Not that one. That one. Yeah, that's all broken. That's fine. Let's see if I can try that stock display there. Over here. Again. A lot of messy code here. So let's just temporarily comment out that remap. Does that really work? All right. Let's see what happens if I get in there with the app. Yeah, that's where this gets interesting as well, as we start to be able to see the, we can see the app's kind of connections going out there. This on. Yeah, I think I broke this when I was 1623. Yeah, that's all ECU originated traffic. It's trying to update the display. Suspicious of my solder connections and stuff on this. But great things to be found in the HTTP. So, all right. Well, I think I'm going to cut it at that. I've been super busy lately, so I'm just going to kind of keep plugging away, and you guys check the GitHub, and I'll be have Bluetooth working on this scooter, and it'll be entirely I don't know. Then we'll worry about making it go faster. So anyway, thanks for stopping by. Just gonna shut it down. So hey, you guys have a great one. Bye.